Hi, my name is Travis English, and this is a presentation that I've given around town. It's called "The Path to Radical Energy Improvement Runs Through Ventilation Code Reform." Um, so, background. Back in 2011, the company that I work for held a design contest where we asked designers to dream up the hospital of the future. We narrowed the contest down to three finalists, and the finalists put together full-blown proposals. And all three of those finalists proposed net zero hospitals. All three of them said that the hospital of the future would be a net zero building. And so my boss at the time told me, he said, you better get out in front of this net zero hospital thing. These guys all talked about net zero hospitals. Our leadership loved it. It's totally lined up with our brand. It's totally lined up with our public image. So this is coming. And hospital buildings are behind on energy to the point that it's becoming embarrassing, really. This chart is energy use per square foot of building. Hospital buildings use about 2.5 to 5 times as much energy as other commercial buildings. So while we might want our buildings to be a good example of environmental responsibility and public health awareness, they're not. And of course, all this energy that we use costs money. And net zero is coming. Not a month goes by without stories in our trade presses about new net zero projects. We've got state energy codes and national energy standards moving to net zero in the next 10 to 15 years. Of course, you could build a net zero hospital right now, and it's been done. You could simply build a hospital and then add a massive on-site solar farm or wind farm. But really, to see a broad movement towards net zero healthcare sites, we need to go on a diet. We need to reduce our consumption. That's what's happening in the commercial sector, and that's what we need to do. It'll be sad if we get to 2030, at the end of the 2030 challenge, and commercial buildings are all low consumption except for healthcare. So, just to get right into the meat and potatoes, when you first think about hospital energy, or at least when I first started thinking about hospital energy, you think about medical equipment and lighting. I mean, there's lots of medical equipment plugged in. We run the lights 24/7. Unfortunately, that thinking is just incorrect. What I've learned is that HVAC is soundly the biggest chunk of hospital energy use. Two-thirds to three-quarters of a hospital's energy goes straight to the HVAC system, and very often the biggest end use is what we call reheat energy. Reheat energy, for those of you that aren't mechanical engineers, is heating energy that we do that has nothing to do with the temperature outside. It's a system inefficiency where we cool down air and then reheat it back up. So equipment loads and lights, those are places where we can save energy. Many facilities already have, but none of them alone or in combination can really move the needle more than 10 or 15%. If you want to talk seriously about reducing the energy footprint of hospitals, we have to look at the HVAC systems. So if any of you are familiar with hospital HVAC design, you've probably seen this table before. When we design hospital HVAC, we use this table. It has air change rates and room pressures. When I was in college studying to be a mechanical engineer, I took an HVAC class. I still have that textbook in my garage, and it has a version of this table in it. So from day one, I learned, hey, this is how we do HVAC in hospitals. We do air change rates and room pressures. That's not how we do any other building, but that's how we do hospitals. And of course, on the right, you have specific temperatures and humidity ranges that pop up room by room. And if you read the HVAC literature, the trade magazines, you usually see these things, these pressures and air changes, next to a paragraph or a statement about reducing hospital-acquired infections. That's something that HVAC guys like to talk about a lot. We talk about reducing the risk of surgical site infections, or reducing the risk of infections in general. So it's very reasonable for a guy like me, a practicing engineer, to assume that these very specific and kind of odd requirements and all this talk about infections, those are related. So when we started talking about net zero hospitals, I started reading up. I've done a lot of reading in the last 5 years, and as a result, I now believe that it's time to rethink the way that we do HVAC in hospitals. So to kind of take you down that road a little bit, let me tell you the story behind one of these. Um, anyone anyone who's used this table knows this number. It's the most common number in the table, and that number is 2 air changes per hour. That's the outside air ventilation number. We use that for most spaces in the hospitals. So I tracked this number back through history. I found it in the code in the 90s and in the 1980s and the 1970s. I found it in versions of this table in the 1960s. I found references to it in the 40s and the 20s and the 1910s. I kept going back, and finally, the earliest reference I found to this number, 2 air changes per hour, was this one. This is in the 1870s, and so I have come to call 2 air changes per hour our horse and buggy number. It predates the light bulb, it predates the car for sure, and really most of the railroads here in the U.S. Just for fun, let me tell you what it was like to be in a hospital prior to the 1870s. Patients were held in wards. They were often unventilated, and they were lit by candles or oil-burning lamps. They did not have bathrooms, so the patients did not bathe. And you would do your business in a bedpan and put it under your bed and then wait for a nurse to come around and empty the bedpans. So if you or I were to jump into a time machine and walk into an 1870s, 1880s hospital, what would strike us most is the horrible, and I mean horrible, smell and hygiene problem that was in the hospitals. This was famously pointed out by Florence Nightingale. So starting in the 1870s and 1880s, architects started putting in ventilation. They put in enough window area to, and I quote, exchange the volume of air twice per hour. So you can find that number, 2 air changes per hour, in the architectural literature of 140 years ago. We still use it today. I've actually spent quite a bit of time going back and looking at the origin story behind a lot of the air change rates that are in this table. And you can kind of see here many of these air change rates. They've changed over periods of time, but a lot of them are pretty consistent and have stood the test of time rather well. This tracks them all the way back to 1959. So here, for example, is a chart of the air change rate required in the X-ray diagnostic and treatment room in healthcare spaces in the U.S., plotted against the actor who played James Bond. And of course, there's this odd number in 1966 where for one code cycle or one publication of the table it required 10 air changes per hour. The only thing I can figure about that is that it roughly corresponds to the single film appearance of George Lazenby. So I did a lot of that stuff. At the end of 2013, I was reading a lot. I was pulling materials from clinical libraries, university libraries. I poured through scientific databases. I put together this huge list of references, a 20-page paper. My wife called it a manifesto. And I sent a draft of it up to our regional director of infection control and patient quality, and she read it for me. I drove up to Pasadena and met with her. And I told her, I said, listen, this is scary. What I'm finding here looks like the emperor isn't wearing any clothes. And I've kind of believed this stuff my whole career. And it looks like there's not a lot to it. So if I'm wrong, please tell me. And we talked it over. She kind of smiled, and she said, "Go get him, kiddo." She called me kiddo. I remember that specific. We wound up a couple years later, or over the course of time, wound up publishing the origin stories behind a lot of those air change rates in the table in a couple of articles, and those have seen a little bit of play. I don't want to leave you with the impression that sort of all the HVAC stuff that we do in hospitals is bogus. That's certainly not the case. There are areas where the intent and the clinical connection is pretty clear, and these are those areas. First and foremost, in operating rooms, we're really doing a rudimentary clean room design. The air changes in the filters are intended to reduce the particle count in the air, and that's intended to reduce the surgical site infection rate. Now, you could argue back and forth about the science for that. There are some studies that support it. There's also studies that look like they debunk it. But kind of internationally, everybody agrees that that's the intent. The same is true for protected environments, by the way. Those are really actually clean rooms. Second, though, we use airborne isolation spaces to prevent the spread of airborne diseases. Now, as a layperson, as an engineer, I used to think that there were hundreds or thousands of airborne diseases. But when you talk to clinical folks and infection control folks, they really only talk about a small handful of diseases, and they are the diseases that you see listed up there: chickenpox and measles and smallpox and tuberculosis. For myself, I'm immunized against most of that stuff, so my real risk is tuberculosis. There are 10,000 cases of tuberculosis nationwide per year, and since the 1990s, we've had a set of design criteria for airborne isolation rooms where we exhaust all the air and we do a negative pressure in the space and all of that. And finally, there are protective environments. Protective environments are spaces for highly immune compromised cases. I've only ever been in one in my life, and that's because my niece Ashley had a double lung transplant about 12 years ago, and so for 2 weeks she lived in a protective environment. That is a dedicated space that's got HEPA filters and positive pressure and air locks, and you scrub in and gown before you go visit her. It's the whole bit. Those are spaces where the HVAC requirements are obviously very critical. Those spaces are also quite rare. The company that I work for serves 12 million members, and we don't actually own any protective environments. So you usually find them at university hospitals or places where you're doing, organ transplants, solid organ transplants, or things like that. So those are the real specialty spaces where we know what the intent of the HVAC requirements is. Well, what about everywhere else? What about all those other spaces in the hospital? Well, those are the spaces where our HVAC practices really don't have a good foundation. And it's not for lack of trying. There have been meta-studies over the years to look into the relationships between HVAC and infections, or HVAC and disease transmission. This is a handful of them on this slide. And these are the literature review studies where they've actually brought together hundreds of clinical papers and sorted through them and tried to find overall relationships. And these are all inconclusive. The only thing that researchers seem to agree on is that we need more research. It's kind of funny how professional researchers tend to always conclude that we need more research. But actually, the WHO paper, that Atkinson paper, has a pretty good statement that I've put at the bottom of the slide, and at this point, this is kind of what I believe to be the truth. It essentially says that if you have poor indoor air quality, air that is less than a hygiene level, that's a liability. That can be associated with higher infection rates. The air in the room that you're sitting, hopefully, is at a hygiene level. At least I hope it is. But once you have air quality that's at the hygiene level, once you have air that's sort of acceptably clean, then we don't really have any evidence to lead us to believe that over-ventilating spaces in hospitals is going to make anything any better. But the real kicker is this. But the real kicker is the 6 air change per hour line, which is way up at the top. You can see that's appropriate for a summer afternoon, but for the rest of the year, that is really over-ventilating the space pretty drastically. Here's the amount of over-ventilation that we do on a summer day in Los Angeles. And here's the amount of over-ventilation that we're doing on a winter day. And all the air that gets put in this room goes through a central system. It gets moved by a fan, then it gets cooled, and it gets reheated at the end. So if you think about this kind of over-ventilation and multiply it times every patient room in the building or every patient room in the country, you can see why the hospital's energy usage is so high. So what I love to do when I talk to mechanical engineers or HVAC engineers is this. I tell them, hey, look, imagine that this table were gone tomorrow. It were just gone. And not only is the current version gone from the code, but I was able to do some sort of freaky sci-fi thing, and all the previous versions had been erased as well. So the table's just gone. It's no longer a resource to you. But I still want the HVAC engineers to do their job. So I show them a job. And this is the patient floor. There are staff areas in the middle of the floor. There's an isolation room in the top right corner. And so I asked the engineers, hey, look, without the table to guide you, could you design an HVAC system to keep all these spaces comfortable, control the odors, have good air quality, and keep the air in the isolation room separated from everything else? And the answer is yes. Of course they can. They're HVAC engineers. And then I like to ask, hey, could you also make it low energy? Could you make it a net zero building? And that's when you see people really start thinking. My biggest point of advocacy is this: we literally don't need the table. We have a whole modern design toolkit for HVAC, and we use that old table instead. In fact, I say that table is holding us back from getting the best thinking that HVAC engineers have to. Because today's HVAC design vocabulary is pretty advanced. In ventilation, we have the ventilation rate procedure. We're on about the third iteration of that. We have design tools for different occupant types, different diffuser types, different system configurations. We actually know the safe threshold for thousands of chemicals and contaminants in air. So we have a pretty good objective standard for measuring that hygiene level of air quality. By the way, quite a bit of thanks to the tobacco debate on that one. And for about the last 20 years, we've had the technology that we call demand control ventilation, where we can measure air quality by proxy and then control the air so that we're putting ventilation where it's needed and when it's needed. We do this in classrooms, we do it in dining rooms, we do it in meeting rooms, we do it in movie theaters, we do it in lab spaces. I've seen a lab building with a multivariable real-time air quality control system that controls contaminant levels in the building and modulates the exhaust based on the wind speed. Very cool HVAC technology. We don't use any of that tech in healthcare. That 2 air change number that we have back in the table just excludes us from using any of that. Comfort is another big area where knowledge has just exploded in the last 30 to 40 years. There was this initial batch of research done on human comfort in the 1970s, but since the green movement has taken off, that has really grown. At this point, we've more or less standardized the comfort survey process, not just here in the US, but internationally. So I can do a thermal comfort survey in a newly built space using a standard protocol and then compare it to the results of a whole lot of other studies, including hospitals from all over the world. And in the HVAC literature, we have that data boiled down into an algorithm to predict the percent of people dissatisfied and the predicted mean vote of a population. So we call that percent of people dissatisfied, PPD, and predicted mean vote, PMV, PPD, PMV. And so we boiled it all down into an algorithm, and then we've incorporated those algorithms into our design tools. So we can do comfort predictions in virtual buildings while we're modeling them during design. And you may have seen stuff like what's in that bottom corner there, computational fluid dynamics, where we're modeling airflow through a space and then showing the comfort outcomes of a human being in there. My favorite is the tool on the right. That's a web-based tool that works in a standard browser window. So I have sat there and run thermal comfort scenarios on my iPad on an airplane. All these tools are available, but really, once again, we don't use them in healthcare because we kind of have this one-size-fits-all design table that trumps the use of all of these tools. But let's go back to energy signatures. This is a set of outpatient buildings. The names have been changed to protect the innocent, obviously, and this is a sample. The portfolio that I'm looking at has over 200 outpatient buildings, and I'm only showing 20 here. But look at the energy signatures. This is energy per square foot, kind of similar to the first chart that we looked at. What you're seeing here is this group of buildings down at the bottom with energy signatures that look a whole lot like office buildings. And then you're seeing this group of buildings up at the top that look a lot like hospitals. We found this phenomenon about 4 or 5 years ago. And at first we thought it might be certain departments or services, like for example, are all the podiatries in bottom buildings or top buildings, but it isn't. It's not that. Then we thought it might be the year of construction, like what year was the building built in. It's also not that. What's happening here is that the buildings up at the top were designed using the air change per hour table. See, in outpatient facilities, that's not required by state codes, but the designers did it anyway. Now that increases first cost a little bit, but it also increases the energy signature quite a bit. Then that whole set of buildings down at the bottom, they didn't use the air change per hour table. And they are less expensive buildings. They're designed like offices or schools or any other commercial space. So not only are they less expensive, but they also use less energy. And then of course the big question here is, can you tell when you're in the building, is the air quality better? Are the occupants in the building more satisfied or anything like that? And the answer to that question is no. The medical groups that practice in these buildings, they literally don't know the difference. They couldn't tell you if they were in one building type or the other. So this is something that we went ahead and made into a rule. We tell our architects and engineers not to use the air change table unless they're specifically required to by law. We actually announced that. We took a little bit of heat for it. The guys who write the code weren't too stoked to hear that. And I remember the first engineer that I had to deal with who was really uncomfortable with this idea. My engineering team reviews the energy of all of our designs. And if an engineer uses the air change table on an outpatient facility, it stands out like a sore thumb. You can see it right away. So my engineer tells this guy, he says, hey, listen, take out the air change rates and rerun this thing like a commercial building and bring it back tomorrow. And the designer said no. He said, listen, those air changes are standard of care. I can't ignore those. That would be unethical. So our project manager calls me. He's pissed off. He says, listen, give me a recommendation for a new engineer out here. I got to fire this guy. It's going to cost me a month off my schedule. Well, hold on. So we got on the phone with this engineer, and ultimately I sent him a letter on KP letterhead with my signature specifically saying, use the other code, use the commercial building code. Now, I don't know if that guy ever got comfortable with the idea, but I do know that he got to finish the project. So that is, use the code that's applicable using the other, or use the other code. But we also do have to look at the healthcare code, look at the hospital code, and talk to the people who are writing the code. And we've been doing that. So when you talk to code people, they kind of have, it's a very difficult job. And the thinking tends to look like this. Hey, look, we've been doing 2 air changes per hour for 50 years. We know that it works. We don't really know that anything else works because we've never tried anything else. And therefore, we really can't propose doing anything other than 2 air changes per hour. And of course, you can switch the argument with whatever you want. We've been using that table for 50 years, and therefore we have to keep using that table. Or we've been using 6 air changes per hour for all those years, and therefore we can't really ever use anything other than 6. It's this sort of self-fulfilling or self-defeating logic. But it really does have a strong hold. And it represents the sort of beliefs of a whole generation or 2 generations worth of hospital HVAC designers. I'll never forget, I was in Seattle and I told a code committee the same story that I just told you guys about the outpatient buildings and how we no longer use the air change table. And this one guy, founding member of the committee, he looks at me square in the eye and he goes, well, Travis, how many people are you willing to kill? And the answer is obviously none. If there was the slightest chance in a million years of that, I wouldn't be talking about it. I wouldn't be talking about it in public. But this is an HVAC guy who had the same textbook that I had in college, and so he was serious, right? He's not even the most extreme one. I had another guy tell me, he says, hey, listen, we do 6 air changes per hour in patient rooms, and before you reduce that to some other number, you need proof beyond all doubt that it'll be safe for patients. And he goes, if you play around with airflows without doing that research, you are doing human experimentation. Human experimentation. I don't know if anyone's ever been accused of human experimentation. Regardless of the logic behind that, it's kind of hard to sleep the night after somebody accuses you of human experimentation. Now, the funny thing is, or at least I think it's funny, that guy wouldn't think it's funny at all, but the committee changed patient rooms from 6 air changes per hour to 4 air changes per hour like 6 months later. They didn't do any research. They just changed it. I mean, and in California where I live, our code actually says that you can do 2 air changes per hour. They didn't do any research behind that either. They just have it different. Here's the thing about the self-fulfilling logic. Both of the highlighted ones there are actually false, or at least they're not true. What this logic says is that healthcare ventilation has only ever been done safely one way and only one way for all time in the history of man, but that's not true. Within 50 miles of where I'm standing right now, there are hospital buildings that were built however many years ago, or maybe they were converted, or they've done something different, either unintentionally or intentionally, or they're operated differently. But bottom line, the HVAC systems in those buildings don't meet the letter of the table as we know it today, and they have patients there. And you know what? It's fine. It's not a human experiment. Nobody's being hurt by the air conditioning. The 6 air changes per hour in the standard issue patient room that we use here in the US, that really only went into code in 1999. And so there are hospitals that where the air systems predate that and they haven't been upgraded because they're very expensive to upgrade and they're fine. You can still serve patients out of those spaces. There's absolutely nothing wrong with that. If you really want to blow the door off the idea that there's only one safe way to do healthcare ventilation, then you go read the international codes. When we did that pilot project in the labor delivery space, we did a comparison of the international codes that we had. So here's the comparison of ventilation rates in the US, the UK, Germany, and Spain. And then the bottom number is that US hygiene level outside air ventilation. So the UK has this pretty wild number for 15 air changes. They would say that we're unsafe. The Spanish standard looks kind of close to ours, but they require 100% outside air. But then look at Germany. They just call for a minimum amount of air. And it actually lines up pretty well with our IAQ thinking, with our hygiene thinking. Our hygiene level ventilation is a little bit higher than what the Germans would say. And since doing this, we've actually taken a look at the French standard, and the French standard is very similar. And we know that the German standard is adopted into quite a few different countries, in the area. The Dutch and the Swiss are using something very like it. And we know that the French standard is adopted in Japan. The Japanese are using something that looks essentially like a copy of the French standard. So all those countries are using hygiene ventilation at really quite a low rate as their minimum. And many of those countries encourage natural ventilation. You can go to YouTube and watch videos of expats having babies in Germany or Asia, and you'll see operable windows, pretty typical in these rooms. So the bottom line is the idea that we have the secret formula for ventilation in the US and that way is the only way that it can ever be done safely, that's just not true. It's not true at all. So what would a code reform look like? Well, here's my opinion. I think we can actually build a new HVAC playbook entirely by the time-honored practice of plagiarism. We just need to pull together ideas from different sources, and this is the outline that we've suggested. We've got to be clear about the clinical spaces. That's paramount to getting past a lot of the mythology. A lot of this presentation was about mythology. Then once we know where the clinical needs are, where they are the driving factor and where they're not the driving factor, then we should be leaning on the best practices of HVAC. The most common question I get when I present this to HVAC engineers is that they ask, hey, what does infection control think about this? And the HVAC guys love to ask that question because they think it's an absolute stumper. Like, oh, infection control would never allow this. But in my experience, I would much rather talk to a room full of infection control folks than a room full of HVAC engineers. Because when I talk to a room full of infection control folks, they tend to get it. Obviously, in operating rooms, protective environments, we want clean air. Obviously, in isolation rooms, we want exhaust and negative pressure. But everywhere else, we really just want to achieve a hygiene level of indoor air quality and keep people comfortable. And they get that, and they tend to get it right away. So that brings us into modern technology. What you see on this slide are air quality measuring devices. See, when we put these ventilation rates in our codes and our standards or our engineering textbooks, those are the best guess at how much ventilation we might need in most cases to get air quality. And in the 1870s, when 2 air changes per hour was our best guess, we didn't have technology like this. Even in the 1970s, the 1990s, this stuff was pretty sparse. But today, the sensors that you see on your screen are Bluetooth-enabled devices. They have networking and data logging. A lot of them are wireless. We no longer need to guess about air quality. In our average hospital, we could hire a hygienist or an environmentalist team with these tools to run an air quality program on the building, and we could actually do that for somewhere between 2 and 5% of the annual energy cost. And if we did that, we could tailor the ventilation to the needs of the space and solve air quality problems where we have them based on real data. So we'd actually have better data on the actual air quality that exists in the building. We'd have real data on environmental safety, plus saving $1 million or $2 million in energy. That would be nice. And of course, save the planet at the same time. We have this technology. It's simply a matter of us starting to use it and starting to use it in healthcare spaces here in the U.S. So that is the presentation in a recorded version. If you got a hold of this link, then I'm sorry that you sat through 30 minutes of this presentation. But there is my email address and my phone number. Please do get a hold of me. It's an ongoing discussion. Thanks.